Hello everyone, good evening. I hope everyone is doing great. So good evening everyone. Before starting, everyone kindly comment that am I fully audible and visible to you all? Yes, okay. So I am fully audible and visible to you all. So today we will discuss about hydrograph. Okay, in last class, in last class we have covered, in last class sir we have covered stream flow measurement. Okay, we have covered stream flow measurement. Today we are going to discuss about hydrograph. Okay, we will discuss what exactly hydrograph is. Okay, so are you all ready? Good evening, Sushil. Good evening. So, basically, in today's class, we are going to discuss what exactly hydrograph is, what are the different components of hydrograph, and what are the factors that will affect the shape of my hydrograph. Okay, so these three topics basically we are going to discuss. So, see, I told you about runoff thing. Okay, I told you what is direct runoff, what is base flow. I hope you remember it. Okay, I hope you remember it. Yes or no? I told you about runoff thing. Okay, sir. Yes, I remember it. So today basically we are going to study about what is hydrograph, what are the components of hydrograph, and what are the factors that will affect my hydrograph. Okay, sir, no problem. So exactly tell me, sir, what hydrograph is. Okay, what exactly hydrograph is. So for that we have to understand a concept. Okay, so for that we have to understand a concept. Listen very carefully. Good evening, Ajay. Good evening, Sushil. Good evening, everyone. Those who are joining. First, we have to understand a concept of catchment area. Okay, you all know what catchment area is, and after rainfall, water flows over the land and reaches the outlet ultimately. Okay, you all know this thing. Okay, sir. So say, let us say this is my catchment area. Let us say this is my catchment area, and in this catchment area, whatever water is there, sir, whatever water is there, after rainfall, you will see that water will run off. Water will run off, and it will join the stream. Okay, it will form a small streams, and that will streams will ultimately drain into the main stream of your catchment. Okay, this we have already discussed this concept. So all the runoff will ultimately form stream flow, and through the network of streams this water will ultimately join the main central stream of your catchment. This you know. Okay, so let us say this is your catchment area. Let us say this is your catchment area, and in this catchment area we have given an input. We have given an input as a rainfall. Okay, let us say we have given an input which is your rainfall. Now you all know that after rainfall most of the water will come into this drain, and at the outlet, see this outermost point, this last point, you all know this last point is known as outlet. Yes sir, we know this. Yes sir, we know this. Now what we have to do after rainfall, what I'm interested in, that this discharge will increase, because after rainfall the discharge will have to increase. Yes or no? Yes or no? Tell me. Yes or no? Sir, discharge has to increase after rainfall. That is for sure. That is for sure. Yes or no? So what will happen here? What will happen here? If I will draw a graph, if I will draw a graph of discharge versus time, sir, if I will draw a graph of discharge versus time at outlet. See, I am telling you, I am drawing a graph at outlet only. I am not measuring discharge here. I am not measuring discharge in the river at this point. I am measuring discharge only at the outlet. I am measuring discharge only at outlet. Yes or no? At outlet of catchment. The last point. I am measuring discharge only at outlet of catchment. Not anywhere else, sir. Not anywhere else. Okay. Sir, what will you observe that before rainfall, the discharge was constant. Listen very carefully. Sir, before rainfall, the discharge was more or less constant. But after rainfall, let us say at this point of time, see, on the x-axis we have time. You all know this. On the x-axis, sir, we have time. Yes, sir. On the x-axis, sir, we have time, and this time is increasing. So let us say from this point of time we have certain amount of rainfall. We have certain amount of rainfall, and this length is indicating the duration of rainfall. Let us say 2 hours. Okay, let us imagine rainfall has happened in this catchment area for 2 hours. Okay, so what will happen? As soon as your rainfall will start, from this time, I will call this time as 0, and you will see that the discharge at outlet, okay, it is a river, and at this point of river, at the outlet point, you will see that the discharge will increase. Immediately after rainfall, you will see discharge will increase. Even after the rainfall has stopped, listen very carefully, Sir, even after the rainfall has stopped, even then I will see that this discharge goes on increasing. Can you guess why? And after some time, see, rain has already stopped. Rain has only happened for 2 hours, sir. Rain has happened only for 2 hours. But see, this rainfall, you can say, has fallen on this entire catchment area. Okay, this entire catchment has received the rainfall, and that too for 2 hours. Yes or no? Yes, sir. The entire catchment has received the rainfall, and that too for 2 hours. Yes, sir. That is sure, that we have understood clearly. But we need to understand one thing here is, sir, the thing which you have to understand is that, uh, sir, even if rainfall has stopped, then also I can see that discharge is going up. Sir, why is it so? Why is it so? Because you need to understand that all the rainfall which has happened here, it will reach at the outlet. It will reach at the outlet, but after some time. Sir, this water has to travel a long distance. The water which has fallen here has to travel a long distance. Yes or no? Yes or no? So, if I am plotting the discharge versus time graph at outlet, obviously it will show a lag. It will show a time gap. It will show a lag. Why? Sir, because water takes some time to reach your outlet. Okay. So, I will see the moment rainfall has started, immediately, sir, your graph will start shooting up, because some water will directly fall on the channel. Some water will directly fall on the channel, and because of this, you will see a sharp rise. It will go on increasing as your water is coming. Okay. The more the water comes, the more the graph goes up. And after after the entire catchment has contributed, this graph will start coming down. This graph will start coming down, and it will become constant again. It will become constant again. Okay. So this is the discharge versus time graph at the outlet of catchment. At the outlet of catchment. Okay. And we have given an input as a rainfall. We have given an input as a rainfall, and I want to check how my catchment has responded. How my catchment has responded to this rainfall. And this graph which we have drawn, known as discharge time graph, also known as hydrograph. You all know what hydrograph exactly is. Okay. This is known as FRH. This is known as flood runoff hydrograph. Okay. This graph which you have drawn, this graph, sir, which we have drawn is known as flood runoff hydrograph, also abbreviated as FRH. Okay. So my catchment has received a rainfall, and after rainfall, my catchment has responded and it has given me a graph which is known as flood runoff hydrograph. Okay, flood runoff hydrograph after a major storm. After a major storm. So is this thing clear? This is very important. Yes or no? This is very, very important. Okay, sir, no issues in that. Now you need to understand one thing, sir. Sir, from where this water is coming, which is, sir, you need to understand one thing. Sir, rainfall was not there, sir. Before some time, rainfall was not there. But even then also, I can see some water was there in the river. Sir, when rainfall was not there, then also some water was there in the river. Yes or no? And when rainfall has stopped, you can say, sir, you can say one thing. Sir, one thing is for sure. We can see that during this time duration, listen very carefully. This is the time duration. This is the time duration during which the effect of rainfall is there in the catchment. This is the time duration from, let us say, 0 to 48 hours. Sir, rainfall has happened only for 2 hours. Rainfall has happened only for 2 hours, but the effect of rainfall is there, let us say, for 48 hours, 2 days. Even rainfall is for 2 hours only, but effect of rainfall, sir, effect of rainfall is there at the outlet. Okay, because when water has fallen here, this water takes time to reach the outlet. You all should appreciate the fact that the area of this catchment is very huge. Okay, let us imagine 500 hectares, 500 kilometers square, like this. Okay, very big areas, very big areas. So obviously this water will take time. Obviously, sir, this water will take time to reach the outlet. That's why rainfall duration, even rainfall duration is very less, but the effect of that, okay, on my hydrograph will remain for long time. the effect of rainfall remains there for long time, okay, because this water slowly and steadily comes to your outlet, okay. But you know, you have to understand one thing, that when in developed cities, or let us say in city area, this water reaches outlet very quickly. Why? Because proper drainage system is there. In cities, you should understand that you must have witnessed that after rainfall, all the water ultimately goes into drains, and that drains ultimately drain off into the main river of your city, and water will immediately reach there within some 3 to 4 hours, okay. So you must have observed this, that after rainfall has stopped, then also you can see runoff, then also you will see stream flow after which is continuing for a long time after rainfall, okay. So ultimately what is the thing here is, sir, the input is, if I want to understand what you have told, if I want to summarize, listen very carefully, if I want to summarize, sir, input is rainfall, okay. Sir, if I want to summarize, input is rainfall in this catchment area, input is rainfall in this catchment area, and the output is, tell me, the output is what? After rainfall, I want to see how my catchment area has responded, and for that I am drawing a hydrograph. Yes or no? So what is the output? What is the output we are getting here? The output which we are getting here is hydrograph. Okay, the output which we are getting here is flood runoff hydrograph. Okay, sir. And let me tell you one thing, sir. This graph which you are drawing for this is a graph of discharge time which you are drawing from outlet, only for outlet point. You are standing at this section, okay, you are standing at this section, or you can say simply with the help of meters or gauge, I will measure the discharge versus time, okay. I will measure the temporal variation or timely variation of discharge, but that discharge versus time graph, this flood runoff hydrograph, will help me, okay, will help me in indicating, it indicates, sir, it indicates both the things, sir. It indicates firstly how your rainfall is, okay, sir. It indicates rainfall characteristics, and it also indicates how my catchment area is, sir. It will indicate how rainfall is, sir. Is rainfall intensity higher, okay, sir? Is rainfall intensity lower, yes or no? Is time duration of rainfall more, is time duration of rainfall less? So it will indicate rainfall characteristics, okay. Sir, rainfall has fallen in this area only, or rainfall has fallen in this area, like this. You will get the indications on your graph. Only by seeing the graph, only by looking at the graph, you will understand what is the rainfall characteristics. Is it intense rainfall? Is it a rainfall of lesser duration? All these things you will understand only by simply looking at this output graph, this output hydrograph, okay. And what else, sir? I will also get the idea of, catchment characteristics. I will also get the idea of catchment characteristics. Sir, how is this possible? I will also get the idea of catchment characteristics. Listen very carefully. See, this is very, very important. Very minute questions have been framed from this topic in examination. So you need to understand. Okay. Okay. So catchment characteristic means, is my catchment area big? Is it small? Or the slope at which water is traveling, is it steeper or is it mild? How my slope is? What is the size of catchment area? Okay. Is the number of streams more? Is drainage density more or no? So all these things. What is the land use pattern? Are there any forest, or are there any roads? So is my land fallow? So all these answers are indicated only with the help of this hydrograph, okay. Seeing only by looking at this hydrograph, you can get the idea of how your catchment is, okay. What is the size, what is the shape, and all the characteristics you will understand only by looking at this graph. So rainfall characteristics and catchment characteristics both are indicated by this hydrograph, okay. So I hope this thing is very, very clear to you. And one thing I want to tell you, that in this chapter we are only dealing with surface water hydrology. Let me write here. In this chapter, sir, we are only dealing with surface water. Sir, why you are saying surface water? Sir, tell me. This I want to understand. Sir, you are saying we are only interested in the water. Sir, we are only interested in water which is reaching your outlet quickly. See, one thing you need to understand. In the runoff chapter, I told you. In the runoff chapter, I told you one thing. Sir, tell me what you told. See, in the runoff chapter, I told you, sir, whatever runoff is there, sir, whatever runoff is there, that is divided into two parts. Sir, that is divided into two parts. Yes, sir. Sir, the first part is quick flow. The first part is direct runoff. Do you remember this? Kindly comment yes or no. Do you remember this? Sir, you told me that runoff is divided into two components. Sir, one which reaches the outlet quickly. Sir, one which reaches quickly. This is quick flow. This is quick flow. And sir, some part of water after rainfall reaches, you can say, at outlet for after a very long duration. Okay, it reaches after taking too much of time, and that part of water is known as base flow. And that part of water is known as base flow, sometimes also referred to as delayed flow. Sometimes also referred to as delayed flow. Okay, sir. Sir, you are saying simply the water which is already there in the river, the water which is already there in the river before rainfall, and the water which is already there, and the water which will be there after the rainfall, is none other than base flow, because the river is every time contributed by base flow even after rainfall has stopped for a very long time. See, rainfall will stop in 2 hours, and the effect of quick runoff will also stop. See, whatever water has to reach quickly, that will stop, let us say, after 48 hours. Example, I am just taking an example that rainfall has happened for 2 hours, and the effect of this rainfall has stopped, or the quick runoff, the direct runoff, okay, the water which has to reach outlet quickly, that has taken place, let us say, for 2 days. But what after that? Even after that time, you will see that some water is reaching in your river. You will see that some water is there in the river. What is that? That is base flow. So base flow contribution will always be there. If you have some water in your river, you need to understand that is none other than base flow. That is base flow only. Okay, that is base flow only. Okay, so I hope this thing is clear. So ultimately, sir, you are saying that even after 48 hours, whatever water is coming into your river is your delayed flow. So total rainfall is divided into two parts. Sir, you are simply saying that when I will start the rainfall, from here to here, we have two parts. See this entire graph. Sir, see this entire graph. Let me tell you one thing. Sir. Let me tell you one thing. Sir, this entire graph can be divided into two components. Okay, sir. Sir, see. Let us start the rainfall from this starting point. Let us say for 2 hours. This is the duration of rainfall. Okay, as rainfall started, you will see this graph will start will be going up, and after some time its effect will finish. Okay, the time duration after which the effect finishes off is known as base time. TB. Sir, we can see that this graph of discharge versus time, is known as flood runoff hydrograph. Sir, is known as flood runoff hydrograph. Understood, sir? Now what I will do, I will separate the quick flow and the delayed flow. See, this flow was already there in the river. Sir, this amount of water was already there even if rainfall was not there. Then also this flow was there. So I will divide, and this amount of volume of water has reached the outlet quickly. See, the above portion is indicating direct runoff, quick runoff. Yes or no? Yes, sir. So if I want to separate this direct runoff, what I will do? I will remove the base flow. See, the water which is already there in the river, that is base flow. The water which is already there, that is known as base flow. So what I will do? From this total, let me write only a single arrow here. Okay, what I will do? I will separate base flow. I will separate base flow This is very important concept. From total flood runoff hydrograph. Okay. So let us say this is your stream. In this stream, this discharge was there. Okay. Let us say this discharge was 5 meter cube per second. It is there. But moment rain has started, you will see that this discharge will increase from 5. This discharge will increase from 5 and it will shoot up. It will reach a peak value. Okay. It will go up to a peak value. Yes or no? This is a peak value. This is the peak value. It will increase and it will go up, and after some time this discharge will increase and again it will come down, and again it will be 5. So this 5 is base flow. This 5 is base flow, which will be there even before and after rainfall, which will be there even before and after the rainfall. Yes or no? So what I need to understand from here is, sir, if I will separate base flow, sir, base flow is always there. That is the delayed portion that will continue for long time, even after rainfall and before rainfall. Before rainfall, it is there because of some previous rainfall. Before rainfall, the flow in the river is there because of some previous rainfall delayed flow. Okay. So I will remove it. When I will remove this base flow, I will get only the top portion. I will draw it. I will only get the top portion, which is known as, can you tell me the name of this? After removing my base flow, whatever I am getting is, that is simply, that will see, that will start from, see, already 5 was there in the river, but now I am only interested in the quicker part. Now I am only interested in the quicker portion. Sir, now I am only interested in the quicker portion. So this is your direct runoff hydrograph. Sir, this graph is indicating me, direct runoff hydrograph. Okay. DRH. I will abbreviate it as, sir, DRH. Okay, sir. No problem. This is your discharge time graph and it will start from 0. Why this is 0? Sir, because you need to understand, let us say in my river 5 meter cube per second discharge was there, but now it has reached 10. So I will see this 10. This total is FRH. And this is your base flow initially. So what is the extra portion which has reached quickly to the river? What is the extra amount of volume of runoff, or what is the extra value of discharge which has reached the river quickly after the rainfall? Immediate effect of rainfall. We can say it is 5 only. I will say what, sir? I will say that this direct runoff is the immediate effect of rainfall that will be, you can say, highlighted, or that will be reflected at the outlet of the catchment. The water which reaches quickly will be indicated by this upper portion only. This is what? This is my direct runoff hydrograph. Okay. So what I have understood from here, sir, I have understood one thing here is the main formula. Listen very carefully, that FRH, if you want to find the ordinate of FRH, what I have to do, the ordinate of FRH is what? DRH ordinate. The FRH ordinate is what? DRH ordinate plus base flow. DRH ordinate plus base flow. Understood, sir? So see what ordinate is. Sir, ordinate means the quantity which is written on y-axis. The quantity which is written on y-axis. Sir, the quantity which is written on y-axis is known as ordinate, and it is none other than discharge. Sir, it is none other than discharge. Sir, discharge is written here. So we are saying that when we are calculating total discharge, so total discharge due to a flood, due to a rainfall, due to a severe storm, due to a major storm is simply because of the quicker effects which will happen immediately after the rainfall. This is the discharge which will reach quickly after the rainfall, and this is the discharge that will reach after very long time, which will be there already. So is this thing clear to you? So simply, sir, I am saying that FRH discharge is equal to DRH ordinate plus base flow. So when I will remove this base flow, I will get the quicker effects. This DRH ordinate is simply indicating this graph, this DRH graph indicates, or let me write in new line. Here, the DRH, direct runoff hydrograph, indicates what? Sir, indicates indicates quicker runoff or indicates immediate effects, indicates immediate effects of of immediate effects of surface runoff. Okay, surface runoff after rainfall. Sir, that's why I'm interested. See, I'm interested in this one only. I'm interested in this one only. Sir, why? Because base flow is already there in the river. Sir, base flow is already there in the river. Sir, I'm interested in the DRH part. Why? Sir, I'm interested in the DRH part because the moment rain starts, okay, the moment rain starts, and let us imagine it is a severe kind of rain. So what will happen? Immediately your level of discharge or the flow in the river will start rising sharply, and we have to control it. As an engineer or as an hydrologist, sir, we have to control it. We have to make sure that no flood is there. Okay, damage due to flood is not there. So we are interested in direct runoff. We are not interested in the base flow. Okay, sir, we are interested in this direct effect. That's why I'm saying that this is your surface water hydrology. Why? Because surface water, the water which directly falls on the surface, runs off quickly. Okay, the water that will reach quickly is your surface water only. Some surface water or some water which is going just below the ground and flowing, that is interflow. So we are interested in the rapid interflow and the surface water which is reaching quickly. That's why the name surface water hydrology. That's why the name surface water hydrology is there. So I tell me, is this thing clear? So tell me, is this thing clear to you? Okay, let me drink water. Wait a second. Tell me, is this thing clear to you? Yes or no? So basically, till now we have understood. Basically, sir, we have now understood that FRH is equal to DRH plus base flow. This is the main thing which we have understood till now. Okay. Now we'll move ahead and try to understand what are the components of hydrograph. Okay. Now we are going to discuss the components. So, sir, what you have told me that at outlet of catchment, okay, sir, we will draw a, we will draw a Q versus time graph. Okay, we will draw a discharge versus time graph known as, tell me, that will be called as, that will be known as flood runoff hydrograph. Okay, and you need to understand one thing, that after rainfall, whatever runoff is there, that will get converted into stream flow. And we have understood the stream flow measurement chapter, sir. I know exactly how to measure the discharge in any kind of a stream. We have understood different kind of methods. Okay, so all these things are clear to me. How to measure this discharge, I know this. How the discharge is plotted, I will measure it at every moment. Okay, many things are there. So I hope this thing is clear now. Now we'll move ahead. And we have understood what is flood runoff hydrograph. If someone asks you like what flood runoff hydrograph is, you will tell this is the total discharge in stream. This is the total discharge in stream versus time at any section. And the section which we have considered is outlet. So this is your Hello, hello. Am I audible now? I think I am audible now. Kindly comment once. Kindly comment if I am audible. Then I will start. One boy is asking, sir, last year pre cleared and mains missed by 4 marks, sir, but this time pre also not clear. Am I waste? No. For sure, no. You are gaining experience. Just don't give hope and keep continuing. Okay. Just continue. I have seen many examples. Okay. I have seen many examples like this who who have qualified for the first time but haven't qualified for the second time, but in third time they have got all India rank 7 like this. So the thing is that you should not stop. Okay. The thing is that you have to continue for a long time. Obviously great results require time, so you have to continue. Just don't stop, you will see the magic. Okay sir. Now you yes, so till where have you understood? I think till here everything was clear. Yes, I was telling you about types of storm. So I was telling about simple storm and complex storm. See, simple storm is a one in which intensity of rainfall is constant. Okay, we will have a simple intensity of rainfall. We will have a simple one, you can say simple, not same intensity of rainfall. Okay, we will have same intensity of rainfall. That let us imagine 5 centimeter per hour, which is continuing for 2 hours. But in complex storms, sir, what will be there? Sir, in complex storms, sir, I will see that intensity of rainfall will change like this. It will change. Okay, rainfall intensity will change like this. So let us say intensity of rainfall is 7 here, 6 here, 6.5 here, centimeter per hour. Obviously intensity is written in centimeter per hour. Here it is in time, obviously. Okay, so let us say 2 here, 4 here, like this, centimeter per hour. Okay sir, why you are telling me about intensity? Now you need to understand one thing. Let me give you the value of phi here. Let me give you a value of phi here. Let us say the value of phi here is 3. Let us say the value of phi is equal to 3 centimeter per hour. Okay, imagine value of phi is 3 centimeter per hour here only, here also, here also. So can you find the excess rainfall? Can you find the rainfall excess? Listen very carefully. Can you find the rainfall excess? Yes sir. Sir, rainfall excess is what? Sir, if I want to find rainfall excess, let me write here. See, rainfall excess means yeah, or excess rainfall means effective rainfall depth. Effective, sir, what does that mean? Effective, sir, what does that mean exactly? See, that means the portion of rainfall depth. Effective rainfall depth means the portion of total rainfall which has contributed to direct runoff, or you can also call it as direct runoff depth. The portion of rainfall, sir, see, this will be indicated by R. This can be indicated by R, or sometimes we call it effective rainfall depth. Okay, sometimes we call it as direct runoff, sometimes we call it as direct runoff depth. Okay sir. So if I want to find, sir, this rainfall excess, let us call it as R, because R will indicate runoff only. What we have to do? So from total rainfall, we have to subtract infiltration. Okay, sir, total rainfall will be given by total rainfall. Tell me the value of total rainfall here. Sir, 5 into 2. Sir, the value of total rainfall is I into T. And the value of infiltration is phi into T. Value of infiltration is phi into T. Okay, so 5 centimeter per hour. So in 2 hours, how much rainfall? Sir, in 2 hours, 10 centimeter rainfall. Yes or no? And phi is what? Sir, 3 centimeter of rainfall is going into the ground every hour. So in 2 hours time, 6 centimeter will go into the ground. So 10 minus 6 is, sir, 10 minus 6 is 4. So rainfall excess, the extra portion is 4 only. The extra portion is 4 only, sir. Okay, the extra portion is 4 only. So this is your effective rainfall, excess rainfall. Okay, see, this is 4 and this is 4. The part which will go into the form of runoff, we will indicate it by R. In the entire chapter, I will indicate rainfall excess by R. Okay, important. Can you find the excess rainfall in case of complex storm? Sir, in complex storm case, let us say this is 3. Okay, let us say this is 0, 1, 2, 3, 4 and 5. So tell me the amount of excess rainfall or simply runoff in first hour. 7 minus 3 is how much? See, tell me the runoffs. Tell me the runoffs. Let us find runoffs here quickly. In the first hour, the runoff is, tell me, 7 minus 3 into 1. 7 minus 3 into 1 is what? 4. So 4 centimeter in the first hour. In the second hour, sir, 6 minus 3. So in the second hour, 6 minus 3 is what? Sir, 3 only. Okay, 6 minus 3 is 3 centimeter per hour. Multiply by 1 hour. Multiply by 1 hour because here we have 1 hour. Okay, so that will be 3 centimeter. Okay, sir. Then 6.5 minus 3 is 6.5 minus 3 is 3.5. Sir, but in the fourth hour, will there be any runoff? No. All the water which is happening, okay, all the water which is falling will go into the ground itself. Okay, here we have runoff in the first hour, second hour, third hour, but in the fourth hour, we will not have any runoff. You all know this. Okay, you all know this. And in the last hour, in the fifth hour, 4 minus 3 is 1. So I will have 1 centimeter excess rainfall. Excess means the part which will convert into runoff. You all know this. So this will be equal to 4 plus 3 is 7. 7 plus 1 is 8. 8 plus 3.5 is 11.5. Okay, so this is how you find runoff. You all know this. So this is rainfall excess. Okay, this is rainfall excess, and I will indicate. See, I will cut this portion from here. I will cut this portion from here. Okay, sir. I will cut this portion of from here, and I will paste it. I will paste it in the hydrograph. Wait a second. Wait a second. Components. Okay, no problem. I will cut this portion from here and paste it here in the. See, this portion is cut off from wait a second. Okay, so this is your. Now I will draw the final hydrograph. Okay, so sir, this is the portion which is showing you excess rainfall. Let us imagine we have 4 centimeter excess rainfall. Okay, I hope this is clear to you. So now we have 4 centimeter excess rainfall, which I will paste here. Okay, I will paste it here. Sir, you are saying we have some excess rainfall. 1 centimeter, 2 centimeter, it can be 3 also, it can be 4 also. But I am telling you how you have evaluated excess rainfall. How you have evaluated excess rainfall or effective rainfall depth? I will call this as effective rainfall depth. Okay, I will not write it here. Wait a second. I will write it here. This is your. This is not. See, the area will be. The area will be 4 centimeter. Okay. Shall I write it here or? Okay, let me write here. This is your effective rainfall depth. Okay, sir, no problem. Now, when this effective rainfall depth will start, sir, the moment it will start, I will see my flood runoff hydrograph will shoot. My flood runoff hydrograph will shoot up. It will shoot up. Definitely, sir, it will shoot up. And after a certain point, you will see that it will change its shape like this. Like this, it will come down quickly. Sir, what these 2 points are indicating? What these 2 points are indicating? See, you need to understand some things from here. Sir, the time duration for which the effect of rainfall is continuing is known as base time. The time duration for which rainfall has continued is known as duration D. Okay, and the total duration for which the effect of rainfall is there, the total duration for which the effect of rainfall is there in the catchment is known as base time. Okay, is known as base time. Now we'll try to understand all the components one by one. So this is your base time. Understood, sir? What else? What else, sir? This is the total duration of rainfall. This is the total duration of rainfall. No problem, sir. That also I have understood clearly. This is your peak discharge. Sir, this is my peak discharge, QP. QP is peak discharge. Okay. And you need to understand one thing. The time taken for peak to come, the time taken from the start of rainfall for the peak to arrive is indicated by TP. TP is what? TP is what? Time to peak discharge. TP is what? Time to peak discharge. Okay. TP is what? Time to peak discharge. No problem, sir. This is TP. This is TB. Okay, sir. What else? We have one more time known as lag time. We have one more time known as lag time. Listen very carefully. We have one more time known as lag time. What is the meaning of lag time? Wait a second. See, what is the meaning of lag time? We need to understand. What is the meaning of lag time? Lag time means, listen very carefully, lag time means what? Lag time means what? See, you need to understand, this is duration of rainfall and this is center of rainfall exactly. This is center of rainfall exactly, and you can see the peak of hydrograph has come at this point. Okay, the peak of hydrograph has come at this point. So you need to understand that the center of hydrograph and the center of rainfall are having a time gap. Why? Why, sir? Because you need to understand one thing, that water needs some time to flow. Water needs some time to flow after your rainfall has happened. It will take some time and then it will reach your outlet. So obviously it will take some time. And because of the time, you will see that peak will come. Obviously, because of that, you will see that peak will come after some time. The peak will come after some time. And this time gap is known as lag time. This time gap is known as lag time. Okay, so I hope this thing is clear. This time gap is known as lag time. Okay, this time gap is known as lag time, which will be called as distance between center of rainfall, time gap between center of rainfall and center of hydrograph. I will write it here. What is TL? TL is what? Sir, TL is simply time between, TL is simply time lag, TM is simply time lag, or you can say duration between center of rainfall, and center of hydrograph. Duration, or let me call this point as center G2, and let me call this point as G1. So G1 is what? Sir, G1 is center of mass of rainfall. G1 is center of mass of rainfall, and G2 is center of mass of hydrograph. Center of mass of rainfall and center of mass of hydrograph. Understood, sir? So the time gap between them is known as TL. Okay, duration between G1 and G2 is known as time lag. If I want to calculate it, sir, if I want to calculate it, it will be given by, listen very carefully here. See this TL and this TP. See the relation between them. If I want to find the relation between TP and TL, what will, see, this is D. Sir, this is D, and half of D is D by 2. See, the gap from here to here will be D by 2 only. So we need to understand TL will be given in denoted by TL is what? TL is what? TP minus D by 2. TP minus D by 2. Okay. Yes or no? So TL is what? Lag time is indicated by time to peak minus effective rainfall duration divided by 2. This is how you will denote. This is how you will denote lag time. This is how you will denote lag time. Understood, sir? Understood very carefully. Now, and you all know what QP is? Sir, QP is peak discharge. Okay, these are some terms. These are some terms which you have to remember from here. Okay, understood. Now, I will write some points. I will write some points on this graph. Let us say this point is A. Let us call this point as B. Topmost point as C. This point as D, and the end I will denote by E. Okay, and the end I will denote by E. So this is my hydrograph. This is my hydrograph. So listen very carefully now. Okay, sir. So AB will be known as AB. You can see this is known as rising limb. Okay, AB is the rising portion. AB is the rising portion. So I will call this AB as. I will call the part of. I'm telling you components of hydrograph. Okay. See, I am telling you components of hydrograph. So obviously AB is rising limb. Okay, what AB is? Sir, AB is rising limb, or you can call it as succession limb, or you can call it as succession limb, or you can call it as concentration curve, or you can call it as concentration curve, because the volume of runoff is getting concentrated. Okay, sir. Now what else? Now this topmost portion BCD is known as crest segment. This topmost portion BCD is known as crest or topmost segment. Is known as crest segment. Okay, or simply a topmost part. Simply the topmost part. Simply the topmost part. No problem. And this ending portion DE. This ending portion DE is known as falling limb, because the water is falling. Okay, falling limb or recession limb. Falling limb or recession limb, because water is gradually decreasing. So this is your falling limb. Now one thing you need to understand. See, the shape of rising limb depends on both rainfall and catchment. Okay, you need to understand this thing. The shape of rising limb depends on both rainfall and catchment characteristics. Sir, why? Why it depends on rainfall and catchment characteristics? Because, sir, it depends both on rainfall and catchment characteristics because you need to understand, sir, because see, rainfall is happening in the starting 1 or 2 hours. So because rainfall is happening, if this rainfall is, you can say, intense, this graph will rise sharply. So how sharply this will rise, that depends how intense your rainfall is. So obviously the rising limb for sure, sir, will depend. Sir, the rising limb for sure will depend. Okay, the rising limb for sure will depend on rainfall characteristics, and also it will depend on catchment characteristics. Why? Because you need to understand, when water will start to come down, okay, when water will start coming down, see, if slope of catchment is more, this water will run quickly, and this water will quickly reach outlet. And if it will reach quickly at the outlet, you will see that this will be steep. So simply you are saying, sir, that the rising limb or the succession limb depends both on how intense your rainfall is, and also depends on what kind of catchment you have. Is your catchment having more slope? Is the size of catchment more or is it less? On all the characteristics it will depend. So basically it depends on both rainfall and catchment characteristics. But the shape of falling limb, you need to understand this. This question has been asked once in your examination. But the shape of falling limb, listen very carefully. But the shape of falling limb, okay, but the shape of falling limbs depends only on catchment. Depends only on catchment characteristics. Why, sir? Why? Because you need to understand, sir, tell me, you need to understand one thing, that sir, this falling limb DE portion is happening when rainfall is stopped. See, rainfall is stopped in the starting 2 hour only, and this falling limb is taking place, let us say, after 30 hours. So what will be the use of rainfall here? Rainfall is stopped, sir. Now, how this slope will come down, how this water will come down gradually, that depends purely on the catchment characteristics. How is your, like, what is the slope of your catchment? What is the size of your catchment? Okay, on all these parameters, your falling limb shape will depend. Okay. Now what is C? C is the topmost portion. C is the point of crest or peak. Okay, C is what? What is C? C is indicating, sir, C is indicating point of crest. C is indicating point of crest. C is indicating point of crest or peak. Okay. So we haven't, now what is left? See, what is this point B and D is? See, B and D are inflection points. Okay. See, these B and D, these both are inflection points. These are inflection points. See, what is the meaning of inflection points? See, the meaning of inflection point is that curve changes its shape. Curve changes its shape. Listen very carefully here. That curve changes its shape. Sir, how it changes shape? Sir, listen very carefully. Sir, before B, my curve is somewhat concave. Okay, from top it is concave and from bottom it is convex. But after B, it is convex from upwards but concave from downwards. Okay. Sir, after B, my curve is changing the shape. So let us say this is the point of inflection. Curve is initially like this, but afterwards it is like this. Now it is convex from the top portion, but after this inflection point, see, it is convex. Now it will become again concave from outside. So outside it is concave, outside it is convex, outside is concave. So curve is changing the shape. That's why this is known as what? Sir, point of inflection. Okay, slope will be here and here tangent will be here. So you need to understand this thing. So B and D generally both are inflection points. So these are the different components of your hydrograph. What is E? What is this E point indicating? Sir, this E point is indicating end of direct runoff. Okay. Sir, this E point is indicating end of direct runoff. The effect of direct runoff has ended. The quicker portion has come to an end. Okay. Whatever water has to reach quickly to the outlet has come to an end. Yes or no? Yes or no? Tell me. Yes or no? Tell me. Okay. So these are all the different components of my hydrograph. But the hydrograph which we have drawn here is is the hydrograph because of isolated storm. So this is the hydrograph. This is a hydrograph which has resulted from isolated storm. Okay, what is the meaning of isolated storm? That a storm or rainfall is there, and the effect of this rainfall has ended, and then if any rainfall has to happen, it will happen after that rainfall will happen, and you will see hydrograph again. But isolated means this rainfall has happened, the entire effect which has resulted due to this rainfall will end first, and then next rainfall will start. Okay, let us imagine another rainfall has happened before the effect of that rainfall has not ended. Okay, first rainfall is there, first storm is there, and the effect of that rainfall is continuing on the catchment area. Okay, even the effect of the first rainfall has not ended. Before that, your second rainfall has started. So what we will see, the graph will again start increasing from here only. Okay, because the moment rainfall start. So in this case, I will say the storm is not isolated. Why? Because this storm has started even before the effect of first rainfall has ended. So this is your complex storm. Okay, basically what happens in complex storms are basically what happens, that rainfall starts even before the effect of first rainfall has ended. Okay, the effect of first rainfall means runoff. When the runoff will end and then rainfall will take place, then I will call this storm as isolated, because it will not intermix with another rainfall. But if the effect has not ended, and before that rainfall has started, so I will say that both the rainfall will intermingle with each other, and that will be a complex storm. But the graph which I have drawn here is basically your isolated storm. Now we will solve one question, and after that we will end the class. Okay, so tell me, sir, question. So find, I am giving a question here. See, find DRH ordinates. Find DRH ordinates due to the following flood runoff hydrograph. Okay, so flood runoff hydrograph is there. Okay, here I will have time, and here I will have flood runoff hydrograph ordinates. Okay, sir, no problem. So the time duration is given as 0, 1, 2, 3, 5, sorry, 4, 5, 6, like this. Okay, 4, 5, 6, like this. Let us say ordinates are given. FRH is 5 meter cube per second. Obviously this will be in meter cube per second. Okay, 5, let us say 10, 25, 31, like this, 27. Then let us say we have it as 9, and then 5 again. Okay, so now I want to find DRH, but in this question it is saying find DRH ordinates due to following FRH if base flow is 5 meter cube per second. Okay, so how I will find DRH? See, if I want to find DRH, what I have to do, sir, I know one thing. If I want to find DRH, I have to separate base flow. I have to segregate base flow from FRH. So what I will do, I will subtract base flow. Okay, I will subtract base flow. So let us say the base flow at every point of time is 5 only. The question is saying the base flow at every point of time is 5 only. So how you will obtain the DRH? Simply by subtracting. Okay, let me draw this graph here also so that it is more clear. Okay, sir, let me draw this graph here. So this is your hydrograph, 5, 10, 25 like this, 5, 10, 25, 31, 27, 9 and 5 like this. Okay, so this is 5, 10, 25, 31 like this, 27, then we have 9, and then we have 5. Okay, so these are the values which is given in the question. These are the values. This is your 5 again. This is your 5 again. So this is your flood runoff hydrograph. Discharge versus time graph. 0, 1, 2, 4, 5, 6. These are all the ordinates. These are all the ordinates. Okay. Yes, sir. These are all my ordinates. These are all my ordinates. No problem. Now, base flow is 5 every time. Sir, base flow is 5 every time. Sir, we have to simply subtract base flow. We have to simply subtract base flow. Simply remove it. So 5 minus 5 will be 0. 10 minus 5 will be 5. 25 minus 5 will be 20. 30 minus 5 will be 26. 27 minus 5 will be 22. 9 minus 5 will be 4 and 0. So this is your, this is 0. This is what? This is 5. Sir, this is what? Sir, this is 20. This is 20. Sir, this is 26. Sir, this is 26. This is what? Sir, this is what? Only this much. Only this much is 22. This is 22. This is 4. And this is 0 again. So this is what? This is the topmost portion is indicating your, the topmost portion is indicating your DRH. This is indicating DRH. And the base flow of 5 we have separated. The base flow we have separated. So I hope if FRH is given to you and if base flow is given to you, you can find the DRH. You can find the DRH. Okay. So tell me, is this thing clear? Tell me, is this thing clear? Note it down quickly. So tell me, is this thing clear or not? If this thing is clear, then we'll end our class today. Is this thing fully clear to you all? Yes, sir. This is fully clear to me. Now we'll start from tomorrow and we'll discuss factors and everything in the next class. We'll discuss all the factors, what is unit hydrograph, what are the assumptions in unit hydrograph, okay, how to convert DRH to FRH, all these things we'll discuss in the next class. Okay, yes, so we will catch up tomorrow. Okay, so thank you everyone, we'll catch up tomorrow. Good night everyone, stay blessed and keep practicing the questions. Okay, so good night everyone.